Friends, welcome back. In the last video, I promised a lot of code, but we didn't get there. We discussed some important steps. I forgot how much behind the scenes there is to a PyTorch training loop. And I think it's important to spend the time that we did discussing what's going on, because there's a fair few steps, but once you know what's going on, I mean, later on, we don't have to write all the code that we're going to write in this video. You can functionize it. We're going to see that later on in the course, and it's going to run behind the scenes for us. But we're spending a fair bit of time here because this is literally the crux of how our model learns. So let's get into it. So now we're going to implement the forward pass, which involves our model's forward function, which we defined up here when we built our model. The forward pass runs through this code here. So let's just write that. So in our case, because we're training, I'm just going to write here. This is training. We're going to see .eval later on. We'll talk about that when it comes. Let's do the forward pass. So the forward pass, we want to pass data through our model's forward method. We can do this quite simply by going ypred, so y predictions, because remember, we're trying to use our ideal model is using x test to predict y test on our test data set. We make predictions on our test data set. We learn on our training data set. So we're passing, I'm just going to get rid of that because we don't need that. So we're passing our model xtrain, and model 0 is going to be our current model. There we go. So we learn patterns on the training data to evaluate our model on the test data. Number 2, where are we at? So we have to calculate the loss. Now, in a previous video, we set up a loss function. So this is going to help us calculate the what. What kind of loss are we using? We want to calculate the MAE. So the difference or the distance between our red dot and a green dot. And the formula would be the same if we had 10,000 red dots and 10,000 green dots. We're calculating how far they are apart, and then we're taking the mean of that value. So let's go back here. So calculate the loss. And in our case, we're going to set loss equal to our loss function, which is L1 loss in PyTorch, but it is MAE, ypred, and ytrain. So we're calculating the difference between our model's predictions on the training data set and the ideal training values. And if you want to go into torch.nn loss functions, that's going to show you the order, because sometimes this confuses me too, what order the values go in here, but it goes prediction first, then labels. And I may be wrong there, because I get confused here. My dyslexia kicks in, but I'm pretty sure it's predictions first, then actual labels. Do we have an example of where it's used? Yeah, input first, target next. So there we go. And truth be told, because it's mean absolute error, it shouldn't actually matter too much. But in the case of staying true to the documentation, let's do inputs first and then targets next for the rest of the course. Then we're going to go optimizer 0 grad. I haven't discussed this one, but that's okay. I'm going to write the code and then I'm going to discuss what it does. So what does this do? Actually, before we discuss this, I'm going to write these two steps because they kind of all work together, and it's a lot easier to discuss what optimizer 0 grad does in the context of having everything else. Perform back propagation on the loss with respect to the parameters of the model. Back propagation is going to take the loss value, so loss backward. I always say backwards, but it's just backward. That's the code there. And then number 5 is step the optimizer. So perform gradient descent. So optimizer.step. Look at us. We just wrote the 5 major steps of a training loop. Now let's discuss how all of these work together. So it's kind of strange, like the ordering of these. You might think, oh, what should I do the order? Typically the forward pass and the loss come straight up. Then there's a little bit of ambiguity around what order these have to come in, but the optimizer step should come after the back propagation. So I just like to keep this order how it is because this works. Let's just keep it that way. But what happens here? Well, It also is a little bit confusing in the first iteration of the loop because we've got 0 grad. But what happens here is that the optimizer makes some calculations in how it should adjust model parameters with regards to the backpropagation of the loss. And so by default, how the optimizer changes will accumulate through the loop. So we have to 0 them above in step 3 for the next iteration of the loop. So a big long comment there, but what this is saying is, let's say we go through the loop and the optimizer chooses a value of 1. Change it by 1. And then it goes through a loop again. If we didn't 0 it, if we didn't take it to 0, because that's what it is doing, it's going 1 to 0, it would go, okay, next one, 2, 3, 4, 5, 6, 7, 8, all through the loop, right? Because we're looping here. If this was 10, it would accumulate the value that it's supposed to change 10 times. But we want it to start fresh each iteration of the loop. And now the reason why it accumulates, that's pretty deep in the PyTorch documentation. From my understanding, there's something to do with like efficiency of computing. If you find out what the exact reason is, I'd love to know. So we have to 0 it, then we perform backpropagation. If you recall, backpropagation is discussed in here. And then with optimizer step, we form gradient descent. So the beauty of PyTorch, this is the beauty of PyTorch, is that it will perform backpropagation. We're going to have a look at this in a second, and gradient descent for us. So to prevent this video from getting too long, I know we've just written code, but I would like you to practice writing a training loop yourself. Just write this code and then run it and see what happens. Actually, you can comment this out. We're going to write the testing loop in a second. So your extra curriculum for this video is to 1, rewrite this training loop, is to 2, sing the PyTorch optimization loop song. Let's go into here. If you want to remember the steps, well, I've got a song for you. This is the training loop song. We haven't discussed the test step, but maybe you could try this yourself. So, and this is an old version of the song, actually. I've got a new one for you. But let's sing this together. It's train time. So we do the forward pass, calculate the loss, optimize a 0 grad, loss backwards, optimize a step, step, step. Now you only have to call optimize a step once. This is just for jingle purposes. But for test time, let's test. With torch no grad, do the forward pass, calculate the loss, watch it go down, down, down. And that's from my Twitter. But this is a way that I help myself remember the steps that are going on in the code here. And if you want the video version of it, well, you're just going to have to search unofficial PyTorch optimization loop song. Oh, look at that. Who's that guy? Well, he looks pretty cool. So I'll let you check that out in your own time. But for now, go back through the training loop steps. I've got a colorful graphic coming up. In the next video, we're going to write the testing steps. And then we're going to go back one more time and talk about what's happening in each of them. And again, if you'd like some even more extra curriculum, don't forget the videos I've shown you on backpropagation and gradient descent. But for now, let's leave this video here. I'll see you in the next one.